Welcome back, everyone. Today, we're jumping straight into a massive, systemic challenge that's quietly defining our future. We are deconstructing the bloated digital identity stack and solving the absolute headache that is AI liability. Look, as we move into a world swarming with autonomous AI agents making decisions on your behalf, the real question is, how do we control them? And even more critically, who is left holding the bag when they mess up? Let's dive right into this explainer and see exactly how developers are completely reimagining your digital sovereignty from the ground up.
I absolutely love this quote from the source material. You wouldn't build a $1 million hyper-complex robotic arm just to pick up a single piece of sushi, right? You just use two simple sticks. It perfectly hits the nail on the head regarding a core problem we've faced for decades in software engineering. For years, developers have been smashing into this massive brick wall of complexity. To enforce digital rules and actually move physical things, they build these incredibly heavy, monolithic smart contracts. Literally building a $1 million robotic arm for one piece of sushi. It's all friction. It's bloated, over-engineered infrastructure. What we'll see in this explainer is how modern engineers are finally ditching that bloat in favor of elegant, surgical simplicity.
And you know, a huge chunk of that bloat comes right down to identity. The Identity Woman project originally envisioned this highly complex digital stack just to stop AI scams and slop. We're talking decentralized identifiers, verifiable credentials, and personhood credentials, all stacked up just to prove you're a unique human being. Sure, it sounds fantastic in theory, right? But to actually enforce all this, developers had to build incredibly dense, heavy protocols. It basically turned into an impenetrable brick wall of theoretical bloat.
So why was all that bloat created in the first place? Well, it boils down to one word: liability. The brutal reality of the digital world is that you literally cannot sue a machine. So when you blindly click "I agree" on some 50-page terms of service, or when you command a machine through what developers call the sovereign gate, you are committing what's known as an agentic tort. Basically, you're volunteering to be the strategic shield. Because you're the human author bending a deterministic AI script toward a specific action, you take on the absolute, unyielding burden of real-world legal liability. You absorb all the costs when things inevitably go sideways.
Part 1. Chopsticks Engineering.
So let's see how this actually works in practice using Occam's razor. Instead of dragging around some monolithic smart contract system packed with dense legal code, Chopsticks Engineering relies on an ingeniously simple, deterministic, event-driven loop using basic modern webhooks. Here's the breakdown. Step 1. An AI agent requests an action, and the server instantly fires back a dormant, 30-year-old internet status code, HTTP 402 payment required. Step 2. The client's wallet steps in and natively signs a cryptographic proof. Step 3. The client simply retries that exact same HTTP request, flashes the receipt, and boom, the server unlocks the resource. It's incredibly fast, it's lightweight, and it's surgical. Two simple sticks getting the exact job done.
Part 2. Proof of secret.
When you dig underneath all those complex buzzwords like personhood credentials and verifiable relationships, the atomic reality is beautifully simple. That entire wall of complexity just elegantly reduces down to raw, private cryptographic payloads managed natively by your local digital wallet. When an app asks if you're a real human, you don't have to show some heavy, complicated credential. Instead, you just run a local calculation to generate a zero-knowledge proof of knowledge, or ZK poke. You are simply proving a secret, that you possess a valid private key. The proof checks out, access is granted, and absolutely zero personal data gets leaked. It really is the absolute distillation of digital identity down to its pure mathematical core.
Part 3. The Ricardian Ontology.
Now you might be wondering, why did we ever build it the hard way? Well, the technical stack isn't just pure, efficient math. It's actually what we call biased compute. In a classic Ricardian smart contract, developers actively tried to bake dense legal parameters directly into the code. This computational translation layer was intentionally slowed down and heavily structured to enforce human jurisdiction. It was an ontology designed purely to satisfy our age-old legal anxieties about things like liability and consent, and to prevent automated platforms from totally taking over. We literally biased the compute just so humans could be held legally liable. Behind the scenes, there's a massive clash happening between two totally different worlds. On one side, we have wet code. This is traditional human commerce. It's ambiguous, it's relational, and it's forgiving. If a human makes a mistake, hey, we have credit card chargebacks, KYC checks, and apologies. On the exact opposite side, we have dry code, machine law, and it is absolute and uncompromising. AI agents don't have passports, and they sure don't have human context. The fundamental error of the last decade was trying to force these forgiving, bloated wet code systems to enforce rules on unyielding dry code machines. Chopsticks engineering finally abandons that messy fog.
Part 4. The Record of Sweat. So how do we actually prove who is at the wheel? We do it through what the sources viscerally call the record of sweat. This is powered by standards like kernel sign, which you can check out at sign.kernel.community, and ERC 7827 ledgers. Think of it as the ultimate jurisprudence strategy. It functions as a cryptographic proof that actual biological human horsepower was spent to execute a mission. It permanently anchors a bit-perfect digital command to the physical calories burned right out of the edges of the network, the leaf nodes. It serves as an immutable receipt of human authorship and intent, entirely bypassing the need for those bloated Ricardian smart contracts.
To really put the scale of this modern orchestration into perspective, I want you to consider this staggering number: 55.5 million. In a recently verified Sovereign Swarm mission, exactly 55.5 million tokens of metabolic flux, which is basically a digital measurement of human energy, were recorded across 66 precise forensic strikes by a human pilot steering an AI swarm. That massive number is a literal digital monument to undeniable human effort. It mathematically proves, without a doubt, that intense human focus and physical calories were expended locally just to maintain control of the machine.
As we wrap up this explainer, I want to leave you with a final provocative thought. We are rapidly entering an era where AI models generate 80 to 90% of their answers based on probabilistic hardware approximations, which is fundamentally just guesswork. In a world increasingly driven by that kind of automated guesswork, true digital sovereignty means retaining ownership of your intent. So, are you going to blindly trust the black box of the machine, or are you going to anchor your actions in the undeniable physical record of sweat? Thanks so much for joining me on this explainer, and I'll catch you on the next one.